Trig ratios is what the topic is today. We're talking about the 6 main ones. The 6 are sine, cosine, tangent, and then their reciprocals. The reciprocals you may not be familiar with. That is going to be your cosecant, secant, and cotangent. Okay, we'll talk about that in a second. But they're the reciprocal. They're the other ones flipped. Okay, so let's talk about the basics. Okay, I hope that all of you have heard Sohcahtoa before. Sohcahtoa is the acronym used to remember the trig ratios. So what it stands for is sine theta is opposite over hypotenuse. That's your SO, S-O-H. Cosine is adjacent over hypotenuse. That's your CA. Okay. And tangent is opposite over adjacent. Wow, it's an awful J. Okay. That's your TOA. Okay. So we'll see if you buy this way they explained to remember it. Last class didn't, but I've never heard it before. I just remembered. But so here's the flips, so the reciprocals. So cosecant is CSC theta is 1 over sine. So it's the reciprocal of sine. Secant is the reciprocal of cosine. And I'm saying reciprocal, not inverse. They're flipped. Okay, so a little bit different. Cotangent is the reciprocal of tangent. Okay. Now, the way the book explains it to help you remember, because I know it's weird that cosecant is with sine and secant's with cosine. Do you think it'd be the flip? The way they explain it is that every set has one co. So cosecant and sine, secant, cosine, cotangent, and tangent. So every set of 2 has one co. That's what they say. So if it doesn't help you, then it doesn't help you. If you just want to remember, then just remember. But secant does not go with sine. That's the important part. Okay? So co, co, co. Each set has one co. Okay? All right, let's look at some examples. Okay, so use a diagram to write all the trig ratios. So we're just writing the ratios in terms of x, y, and r. Okay? So sine from this little picture here is opposite, which is y, over r. So then cosecant is r over y. Cosine is x over r, and secant is r over x. Tangent, y over x, cotangent, x over y. And this is why when you're doing trig stuff, that sine goes with y, and cosine goes with x in terms of coordinates. And we'll get to that more with the unit circle. When we're talking about coordinates, cosine's kind of your x value, and sine's your y value. We'll talk about that. Okay. Any questions? The basics yet? We're okay? All right. So determining the sign of a trigonometric ratio. So we're just doing the sign chart. This sign chart was also Math 20, but we'll just do it one more time here. And this is just helping you develop the cast rule. Okay? The cast rule just tells you what trig ratios are positive or negative in which quadrant. Okay? So for example, we're thinking about this on an XY coordinate grid. So for example, in this one here, see how up for y is what? Positive, right? R is always positive. We describe that as distance from the origin. So it's distance, so R just maintains a positive value all the time. Okay? So then what we're doing is, that's why plus plus y plus r. We're also plus plus for cosine for x over r. And then we're also plus plus for tangent, which is y over x. So all these signs over here are positive. I'm just going to go through and write these ratios so we don't have to keep doing it. Okay, so there's all the ratios. So you just got to look at them for each one. So in quadrant 2, is the y going up or down? Up. So it's positive, positive. the cosine? That's negative now, right? We're going left for x. So it's negative over positive. That's a negative. So then tangent is a positive for the y, but a negative for the x, so negative. Okay. Quadrant 3. The y is negative now over the r, or sorry, which is positive, so negative. The x is also negative over the positive r, and then y over x is negative over negative. Wow, that's not good there. R is always positive. Yeah. Positive there. Okay, in quadrant 4, y over r, negative over positive, positive over positive, and negative over positive. All right, so what this does is it forms the cast rule. They use say cast, it's an easier word to memorize, but it starts in quadrant 4. So it starts here, 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 and here. So it goes like that, and the way they came up with it is in quadrant 4, cosine is positive. In quadrant 1, all is positive. Quadrant 2, sine is positive, and quadrant 3, tangent's positive. And so the cast rule tells you what's positive where. So every place has 2 places that are positive, 2 places that are negative. Okay? Because they all have the all section. Okay? Sure. Casserole? Sure. Oh, really? Oh, casserole. Oh, okay. So you're saying I enunciate a little better? Okay. So the sine ratio and cosecant ratio. So these are, remember, sine and cosecant, they're the same, just flip. So they're going to have the same signs. When you flip stuff, it doesn't change the sign, right? So sine and cosecant are positive in 1 and 2. Remember I said sine think y, right? So y above the x-axis is 1 and 2. Cosine is positive in 1 and 4. I said cosine think x, so at the right side. So 1 and 4 is the right side of our quadrants. Okay. Okay. And then tangent ratios are positive in 1 and 3. That's a tricky one because 3 is that negative section, which makes it positive for tangent. And then conversely, sine's negative on 3 and 4 because that's the bottom for y. Cosine and secant are negative in 2 and 3. That's left side for x. And then tangent's negative in 2 and 4. And so then there's your cast rule. Cast rule. Okay, whatever helps you remember. Okay, any questions on that stuff? Things so far so good? All right. Determine without using technology where the given trigonometric ratios are positive or negative. So just knowing what quadrant you're in and if that trigonometric function is positive or negative there. So 280. This is what we have to get good at. Okay, 280. 270 is right here. So I'm just slightly past 270 to 280. I'm in quadrant 4. Sine is definitely what there? Negative, because I'm below the x-axis. Tangent, 7 pi over 6. So what I like to do is I use the landmarks of 2 pi and pi. 7 pi over 6 is slightly bigger than pi. So I'm slightly bigger than pi. I'm right here, quadrant 3. Tangent quadrant 3 is positive. Now 10 pi over 3. Now they're wasting my time a little bit, spinning their wheels. I'm going around more than once. Okay, 10 pi over 3. So this is what I was telling Zoe. He's like, you got to think about this. How many 2 pi's can I take out? Well, 2 in terms of thirds is 6 pi over 3. So I'm just going to subtract a 2 out of there. Oh, okay, I'm at 4 pi over 3, really. That's where it's going to land within my rotation. So now I see 4 pi over 3. I'm slightly bigger, again, than 1. So I'm in the third quadrant. So what's cosine in the third quadrant? Negative, yes. Okay. cosecant of negative 225. So now we're going the negative direction. So negative 225 is going to be right here. So I'm going to go 90, 180 to 225. So it's in quadrant 2. Cosecant is with what? Sine. And I'm above the x-axis, so positive. Okay, negative 13 pi over 6. A little silly, slightly bigger than 2, but not much. So it goes around once and then one more sixth, right? Because 12 pi over 6 is 2. So it's really just going to be right there in the fourth quadrant at a pi over 6. So fourth quadrant for cotangent is, what's that? Negative, yep. And then 1,000. I would just minus 720 to that. Take 2 rotations out. 360 times 2, right? 280. So I'm at 280, so I'm just slightly past 270, so I'm still in quadrant 4. Secant goes with cosine, so I am positive there. Okay. All right, any questions on any of those? Leave that too fast. Anything you want me to slow down and make sure explain stuff? All good? Okay. So now they're talking about make sure you understand difference between degree mode and radian mode in your calculator. So if you go to mode in your calculator, you'll see there's degree and radian. It does matter what you're using to calculate when and where. I don't want to say funny question as in like kind of making fun, but like earlier I think Travis was like, so if I'm in degree mode, is that going to mess my calculator up? Well, degree and radian only applies to when you're using trig stuff. So if you're in degree mode, it's not going to mess up your 4 times 4 in your calculator. Okay. What's that? That's what I mean. Depends. It doesn't matter what you're in until you see what you're doing. So like if I have something in radian measure, I'm in radian. If I have something in degree measure, I'm in degree. So it just depends what you're doing. That's so you can't just say there's not one that you're always supposed to be in. Right.
Like every time you see pi, you know you're going to be right.
Correct. So like right here, it says use a calculator to determine these 4 decimal places. So let's just go ahead and do this. Maddie, you can do A. So Maddie, you're going to be in degree for that one. Hannah's going to do B, radian. Bree, can you do C, radian? This one is technically radian, Mo. So do D in radian, okay? Because there's no degree symbol. Okay, so do that in radian. Okay, Zoe, want to do E for me? Sadie, you can do F. And then Ben, I guess you can do G, and we'll come back to Tori later.
What mode do I have to be in?
Which one? What is that? A degree or radian? The pi means radian here. So, yeah, degree sign, right? Look for the degree signs. Okay, I'll pause and let you guys get those and tell me when you're ready. So Maddie, what'd you get for A?
-0.9848.
98, I didn't write that right. 9848. Okay. All right, Hannah, for yours, did you get it?
3.662.
Okay, so put that in. Try that again. Put brackets around that. Yeah, make sure you're in radian too.
Yeah, it is in radian.
Okay, so make sure. I'll come back to you. Bree, what'd you get for C? Negative 0.5, good. Okay, Mo for D? Okay, 0.89. They said 40, but you're probably fine. Okay, good. Zoe for E? Okay, good. Sadie, did you get F yet? Okay, we'll look at that one, come back to that one. And then, Ben, what'd you get for G? 5.75. Okay. All right, so Sadie, make sure it looks like this. Like that. That's how you put your calculator. Make sure you're in radian mode. Okay, Hannah, did you retry it?
I got 5.774.
There we go.
Or 0.5.
Yeah, 0.5774. Okay.
-1.7.
Yeah. Okay, 1.7321. Okay. So you can see it's not as simple putting those in your calculator, so you want to make sure you practice that you make sure you get that stuff when you need to. Okay. All right, let's keep on going here. Okay, just a couple examples left here. All right, so expressing trig ratios and angles in terms of the reference angles. This is what I was talking about to start class. Some of you guys struggle with that reference angle idea, especially reference angles of radians. So that's what we're going to practice here a little bit more, which is a little bit helpful. But what we're going to do for this procedure is, the first thing is we're going to use our knowledge of the cast rule to figure out, should this be a positive or negative answer? And then we're going to figure out what the reference angle is. Because what it is that this value, what happens is that, like for example, if I have this reference angle, right, that happens in 4 locations. The only thing that changes those 4 locations is the sign. So like, for example, let's just say, I'm making this up, let's just say this is 3, 2. If I'm talking about cosine, I said cosine goes with what? X, right? So 3. But what is it over here? It'd be -3. And what's it here? And then 3, right? So there really is a positive or negative answer of that reference angle, if that makes any sense. So this right here, let's just say, just for being easy, let's just say this is pi over 3, right? But if I came over here and I said 2 pi over 3, what's the reference angle 2 pi over 3? So what? So here's pi, yeah, it's 1/3, yeah. 2 pi over 3 to finish would be another third. That's why it's supposed to be the same. I gave that number on purpose. They both are the same distance back to x. And so the point is, their value is going to be 3 everywhere. But what's going to change? Just the sign. Okay? So we're going through, and we're determining the sign, positive or negative. Then we're determining the value, and then we're combining those. Okay? So let's do these examples right here, and I'll show you. So cosine of 7 pi over 4. Where is that at? Well, cosine of 7 pi over 4, that's almost 2, right? Because 2 is 8 pi over 4. So we're just a sliver right here. That's where 7 pi over 4 is. So is cosine positive or negative there? Positive. That's the C. So we know our answer is going to be positive. Now, what's the reference angle? So then how close is it to finishing to 2 pi there? Pi over 4. So then your answer is simply cosine of pi over 4. And so what they're saying is, because 7 pi over 4, do you guys understand that 7 pi over 4 is not an acute angle? All acute angles are going to come from this section, right? Between 0 and 90. So that's where they're making you take the reference angle, since that's acute. Pi over 4 is 45 degrees. And so we're taking cosine of pi over 4 because these 7 pi over 4, essentially, this and this, guys, is the same value. We're just writing it differently. All right. The cosine is. Because look, 7 pi over 4 is right here, right? And pi over 4 is right here. Look at the x. The x is in the same location. And so that's why they're the same. Okay? So cotangent -100. So if I go -100, I'm going to be just past the 90. I'm going to be right here in quadrant 3. So it's cotangent. I'm in quadrant 3, so that's going to be positive. Okay? Now I want to figure out the reference. So what's the, if this is 100 here, how far to get to the 180? 80. So then it's simply going to be cotangent of 80. Now cotangent is a little bit trickier because it's the combination of y over x. So it's not as cool to see like that. If you're like, wait, because it's doing a diagonal. Because it's y over x, so it's a little bit different, but it still means the same thing. So then sine 11 pi over 2. Now this one's a little bit of a waste of time, right? Because it's going around more than once. So 11 pi over 2. So then let's see here. How many times 4, 8, yeah? So I'm doing right now is 8 pi over 2 equals 4 pi, right? That's how many times around? That's twice. So I'm going to minus 8 pi over 2 to this. 3 pi over 2. What's that? 10 over 2. What would 10 over 2 do for me? But, okay, but 10 is 5 pi. And so 5 pi is, you want to take out in 2 pi's. So I use 8 because 8's a multiple of 2 pi. That's why. I see what you're doing. You went to the next whole number. Yeah, and that can help you see how far. So some people see this, though, Maddie, as 5.5. So if it's 5.5, we know that there's 4 in there, right? And so the 1.5 left over, which is 3 over 2. It's all the same. Okay? But the point is, we're at 3 pi over 2. We go around, and we come back, we're at 3 pi over 2. So we're down here. We're right there. Now, for this, is it positive or negative for sine? Well, we're down, so sine's with y, so this is negative. And then what's the reference angle? It's the biggest one you can have. Sine pi over 2. And I just put it, if you're, where's the negative? I just put it in front. Negative sine pi over 2. Okay, so let's finish this up here. All right, so we got, excuse me, the point negative 15.8 lies on the terminal arm of rotation angle theta in standard position. Mark the angle theta on the diagram. So the angle theta is actually this rotation, so that's angle theta. And they want to calculate the exact length of OP equals R. So they want us to figure out how long OP is. And so how we do that is we're going to think about this as a triangle. So that's negative 15, and this side's negative 15. If that's 8, then the vertical is 8. And so we're going to use Pythagorean theorem to figure out what R is. So we're going to go 8 squared plus negative 15 squared equals R squared. 64 plus 225 is 289. So R is 17. The square root both sides. And now it wants us to write all the ratios. Now that we have the x, y, and the r, it wants us to write all the ratios. So the ratios would be sine of sine theta would be y is 8, so 8 over 17. Cosecant theta, 17 over 8. Cosine theta, negative 15 over 17. Secant theta would be 17 over negative 15. Tan theta is negative, or sorry, it's y over x. So it's 8 over negative 15. And then cotan, negative 15, come on. It's not working down here. Yeah, it's supposed to be an 8. It's not wanting to work down this corner for some reason. Try it again. A bad pen day. All right, as good as it's going to get. That's an 8. Try it again, sorry. Okay. Yeah, connect the dots. Not being my friend today. Okay. All right, and one last piece here. All right, so cotangent A equals root 5 over 2. And sine A is negative. Complete the following procedure to determine the exact values of the rational denominators of cosecant A and secant A. Okay, so with those things, we're looking at, since cotangent ratio is positive and sine is negative, angle A must terminate in which quadrant? So cotangent is positive. So if it's cotangent, where is tangent positive? 3 and 1, right? But then it says that sine's negative, so it can't be 1. So it's in 3. Okay. Oh, I didn't freeze it yet. All right, so 3. Since cotangent A is root 5 over 2, which equals x over y, we know that the point then is negative root 5, negative 2, because it's in the third quadrant. So that means it's going to be like negative root 5 and then negative 2. That's where this point's at. So it's like right there. Negative root 5, negative root 2. And then it wants me to draw the reference triangle. So the reference triangle would be, so let's switch up the colors a little bit here. It'll be right here. That's the reference triangle. It's like a little right triangle right there. And it wants me to figure out what R is. So we're going to get R, and we're to find that gives us the values of cosecant and secant. Because to do cosecant and secant, I need to know the R value. So we got negative root 5 squared plus negative 2 squared equals R squared. Just doing Pythagorean theorem. Negative root 5 squared is just 5. Negative 2 squared is 4. So 5 plus 4 is the 9. So that makes R 3. Okay. Since R is 3, we can now do cosecant and secant. So cosecant is going to be, remember, I'll just write it right here. Cosecant is R over Y, and secant is R over X. So would they want cosecant theta or cosecant of A? Cosecant of A is going to be 3 over Y negative 2. And then secant, this whole left side of the board's bad. Everywhere's bad. Secant A, sorry, I'm right up here, getting tired of the dots. Secant of A is 3 over negative root 5. Just got to recalibrate this bottom part, apparently. So, but get the idea. Just leave it like that. Good point. You could rationalize this. They're going to rationalize in your books. I should show you. Remember, to rationalize, you go root 5, root 5, root 5 on top. So your rationalized answer is going to be negative 3. Negative 3 root 5, this is just getting ridiculous, over 5. Yeah, but anyway, that looks terrible. But to rationalize, you multiply by the radical. It's on bottom to top and bottom to get rid of the radical. Back to a little bit of math 20 stuff. Okay. All right, we'll stop there.